Good afternoon, I am Mr. Ish. Thank you very much for joining me for this video. I am presenting to you a very unique feature of this arctan function. You know, arctan is inverse tangent, or you can say as the arctan x. In terms of the derivative, we are presenting you a unique aspect. When you are looking here very generally at the graph of the arctan, the inverse tangent, it is perhaps the most applicable or common inverse trigonometric function that you see with regards to derivatives. It goes right here to the origin, then it shoots up here in the direction of this horizontal asymptote, then it grazes it in the direction of that infinity. In the direction of minus infinity, it has a similar behavior, grazing along this horizontal asymptote. Y equals pi over 2, y equals minus pi over 2 are your asymptotes. In the direction of infinity, as x approaches infinity, your function will approach positive pi over 2, your horizontal asymptote. In the direction of 0 on either right or left, your function is going to approach 0, as you can see right here. In the direction of minus infinity, your function, arctan function, will approach this other horizontal asymptote, minus pi over 2. What is the most unique feature of this arctan function in terms of its derivative? Well, the derivative must always be positive. It cannot be negative and it cannot be 0. Think about it graphically. If you were to draw any tangent lines, the tangent lines would always be to some degree pointing upwards, even here. And you can see the tangent lines are always upward sloping. Even as you near the horizontal asymptotes, you are still having a certain inclination towards the positive, meaning from left to right, your line is always sloping upwards. Here at the origin, you don't have a horizontal tangent line. You cannot draw a horizontal tangent line, hence a 0 is out of the picture. You cannot draw any downward sloping lines, hence the negative derivative outcome is out of the picture. The only outcome which exists is always positive for the arctan or the inverse tangent trigonometric function. What I want to show you in terms of its derivative, why that is the case, but I will show you mathematically why that is the case. If you start with this, y is equal to arctan x. I like to use this. You push this on the other side, you're looking here at now tan y is equal to x. You do its implicit differentiation. You're doing that, you're getting a secant square y dy over dx is equal to 1. You solve for this. Dy over dx is equal to 1 over secant square y. But what was y all along? Y all along was this, which means you can rewrite everything as this. Your dy over dx, your derivative with respect to y, is equal to 1 over secant square y, which is your arctan or inverse tan x. You can generate everything with regards to a right triangle which has a certain angle. This right here represents that certain angle. You're looking here at x over 1, which is x over 1. You're looking here at x squared plus 1. When you're looking at this, at the end result, your derivative with respect to y is 1 over secant square of theta. Theta here is root x squared plus 1. But you have a square of it because you have a secant square. You see the secant square? So you're looking here at 1 over x squared plus 1. What does this 1 over x squared plus 1 represent? It represents the derivative of this. Why is this important to know the derivative? Because it helps us explain the unique feature of the arctan. Mathematically, I told you can only have a positive derivative outcome. You cannot have a negative, you cannot have a 0. Think about it. If x were equal to 0, you're looking here at this derivative factor. You will still have, if x were equal to 0, you'd still have as your outcome 1 over 1, which would be 1. And if you ever were to put a negative in terms of an x, the exponent will always make it positive, and you'd have a positive in terms of your derivative outcome. Your derivative outcome, here you're looking with regards to the y value, is never a negative, it's never a 0, it's always just a positive number. Hence, the unique feature of this arctan derivative comes to light. The arctan or the inverse tangent in terms of its derivative outcomes must always be positive. It cannot be negative and it cannot be 0. And that'll be the end for this video. Thank you for watching.